Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. And they also have a new object storage service to make storing data for your apps even easier. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. Having all of your logs and event data in one place makes your life easier when something breaks, unless that something is your Elasticsearch cluster because it's storing too much data. Chaos Search frees you from having to worry about data retention, unexpected failures, and expanding operating costs. They give you a fully managed service to search and analyze all of your logs from S3, entirely under your control, all for half the cost of running your own Elasticsearch cluster or using a hosted platform. Try it out for yourself at pythonpodcast.com/chaossearch, and don't forget to thank them for supporting the show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the Data Orchestration Summit and Data Council in New York City. Go to pythonpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host as usual is Tobias Macey, and today I'm interviewing Ram Rachum about PySnooper, an alternative approach to debugging your Python projects. So Ram, can you start by introducing yourself?
Sure. Hi, Tobias. I'm happy to be on the show. My name is Ram, and I've been a long time Python developer. I've been involved in open source for a long time. I would say I've been programming Python for 10 years. Most people know me in the Python community as the organizer of PyWebIL, which is the Israeli Python community. We meet once in a couple of months as a meetup in the evening where volunteers from our community give talks about various topics, sometimes Python related and sometimes more general software development related talks. Now, over the years, I've worked in small companies and big companies. I worked for startups and I worked as a freelancer. And recently, I started working for a company called Bluevine. So I've actually only worked there for 4 months. They're a company that does fintech and Israeli-American startups. And so I'm slowly getting to know my new environment. So I've been working there. It's a good place to work. If anyone, we are looking for all kinds of software development and all other kinds of positions, both in the Redwood City, California offices and the Tel Aviv offices. So if anyone might be interested in joining Bluevine, feel free to send me your CV. I've got my the careers page and my email in the show notes. So it's a pretty good company. They closed an investment round of $100 million a few weeks ago. So we are all very happy about that. Another thing I'd like to promote before I get to talking about my main thing is I also give Python workshops as a side business. I have a website, pythonworkshops.co, where I go into detail about my services. But in brief, companies sometimes hire me to come to their offices and give courses. It could be like 3 days or 5 days, where I teach their teams, where I improve their Python skills. Sometimes I get to teach beginners, and sometimes more advanced people. I tailor the courses to the client's demands. So it's a side business I do. If you might be interested, check out my website, pythonworkshops.co. So that's pretty much about me.
And do you remember how you first got introduced to Python?
Sure. I was a poor college student at the Technion in Haifa, and I was reading Paul Grand's essays. For anyone who isn't familiar with Paul Graham, he's the founder of Y Combinator, which is the most, I would say it's the most well-regarded startup accelerator. So I was reading his essays. He's famous for having all of these interesting essays on his website. I don't remember the address, but if you Google for Paul Graham essays, you'll get them. He has very interesting essays about programming and startups and finance. And I was very interested in him, and that was 15 years ago when he was just starting Y Combinator, where it was just the first batch before everyone realized he was a genius. And so many startups like Airbnb and Dropbox came out of there. So I was reading his essays, and in one of his essays, he offhandedly mentioned that Python is a good language. So I sort of made a mental note to myself that Python might be a language I would like to learn. So a few years down the line, when I was getting back into programming, I thought, let's give this Python thing a try. And I used to program when I was a kid. I used to program in C and in Pascal when I was in junior high. And I was always frustrated by all the technical things that you have to remember and all the details. That was very difficult for me. So I figured I hate being a newbie. Being a newbie is so annoying. So I figured I'm gonna take this one language and I'm gonna know it really well, and I really hope I won't have to be a newbie at a language again. And that was 10 years ago, and my plan kind of worked, and I kind of became a Python expert. And I really hope I'm gonna be able to keep on the same language until for the remainder of my career.
Yeah, well, with the trajectory that it's on right now, I think that it's a fairly safe bet, but you can never tell in the area of technology because the fates can be quite fickle.
Yeah, I know lots of people are falling in love with the Rust right now. It's really hot.
And so in the process of learning Python and using it for your day job and doing these trainings, you ran into some of the shortcomings of debugging in the Python ecosystem. So I'm wondering if you can just start by discussing some of the existing state-of-the-art for debugging in Python, some of the shortcuts that people might make, and some of the pain points that you were dealing with that led you down the road of creating PySnooper, and then we can talk a bit about what it is.
So I've always liked using debuggers. Ever since I started programming, I would always do all my work in a debugger. I use a Wing IDE, and I know most people have never heard of it. Most people use PyCharm for their debugging. So it's basically the same kind of software. It's a good program to install, and it's the same old kind of debugger that most languages have. Now I'm very used to using a debugger, and I use it all the time. And I set breakpoints, and I step through the code, and I have my debugger automatically stop on exceptions. And then I can travel up and down the stack and explore any kind of variables or run any kind of arbitrary code, which I find is very useful for figuring out what's happening in your program. So I've done this since forever, and for me this is programming. But when I started working with other people, especially when I started working in big companies, I saw that most Python developers don't use debuggers. And that blew my mind. That really blew my mind. I mean, I was thinking, I'm going to see professional developers who are very, very serious. But it turns out most of them use print statements. Like if they have a piece of code and it's not doing what they think it should be doing and they want to investigate, they add print statements or temporary log statements, and then they see the print output, and then they kind of have an idea of what their code is doing. Like they could add a print statement at a certain point in the code, and then they would know that certain point was reached. And they would add more print statements in different parts, and then they would kind of try to figure out the flow of the program. They would maybe expose a certain variable in a print statement to know what it is. I've done this in the past. We've all done this, but I was a little bit surprised that this method is so common. And the reason it is so common is because when you're working for a company, especially if it's a big corporate thing, the setup is usually very convoluted. I mean, you're working on a project that was inherited to you from someone who inherited it from someone else, and it's usually a mess. And the code that you're writing is not running on your computer. It's running on some kind of other machine that your computer is connected to. And there is probably a complex build process that shuffles your Python code around. And most people don't really know how to connect their debugger, be it PyCharm or Wing IDE or any other program. Most people don't know how to get the debugger to work with whatever convoluted setup their corporate has. So most people just resort to using print statements, which was very surprising to me. Using print statements for debugging, I think that's both. I have mixed feelings about this. I think it's both very beautiful and very ugly. The ugly part, of course, is how ridiculous it is, because you have to insert these print statements manually into your code and then see the output, and then you usually realize you wanted to put the print statements somewhere else. So you do a back and forth, building your project multiple times just to get the information you wanted, which to me is such a frustrating process. So that's the ugly part. The nice part is that it always works. Like, it doesn't matter how convoluted your setup is, you can always print to standard out or at least write to a file. And this is the reason everybody uses print statements at some point or another, because it's so resilient. It works everywhere. So I'm getting to my point about what is PySnooper. So I was thinking after many years of seeing people use print statements, I was thinking maybe I could do a compromise. Maybe I could provide a solution that is as resilient as print statements and as easy to use, but a little bit more powerful like a debugger. So that's what PySnooper is. So I'm going to describe how someone would use it and what it provides. Let's say you wanted to use PySnooper to debug your code. So obviously you do a pip install PySnooper and import PySnooper. And then you go to the function in which you want to understand what's going on, and you decorate it with the PySnooper.snoop decorator. And what that does is it basically does a sort of automatic log to your function, as if you put a print line on each and every line of your function. This means that when you run your code, you're going to get a sort of output text dump of all the lines of your function that ran, one by one. And anytime a variable got changed, you're going to get a line saying variable x changed and its new value is this and that. Sort of instead of going back and forth and adding print statements, it sort of just automatically prints everything you might need. And then you can take this text output and look at it and sort of figure out the play-by-play what's going on in your function. So that's the gist of the solution.
Yeah, as you mentioned, print statements are easy to get started with. They work all the time, but then there's also the added issue of you need to make sure that you actually go back in and delete them so that they're not running in production and potentially leaking information into log files or into just the standard output. So that's one of the areas where using log statements are a little bit preferred, because you can set them as debug or error level, so you can have a little bit more control about when they show up, but it's still littering your code base with a lot of extra information that is only useful in a particular context and might be useful down the road to expose it to people. But like you said, there's the back and forth of, oh, I want it here. No, actually, I wanted it there. And oh, I actually needed to know what this other variable was. And so as the program evolves, those log statements and print statements become a lot less useful. So I'm wondering if you can talk through a bit now about what PySnooper is and some of the problems that you're solving.
So PySnooper, it doesn't aim to be like a strong, very advanced debugger. It aims to be a cute little tool that fills the hole in the market as far as debuggers are concerned. So it's not aimed to be a very, very powerful thing, just something that answers a very specific need. What was the rest of your question?
Just wondering if you can describe a bit more about sort of what PySnooper is and some of the issues with print-based debugging or log-based debugging that it addresses.
The main issues are that you have to go back and forth. You have to build your project multiple times. Especially in big corporates, the build process can be slow. Sometimes it can take a few minutes to build your projects. And I'm sure that some of our listeners are working in terrible corporate environments where it takes more than a few minutes to build your project. So having to do the back and forth of building your project multiple times, that's such a drag, and PySnooper helps to avoid that. And also having to kind of guess the information that you want to expose, having to write the string formatting lines that kind of expose this variable and that variable, having to do it manually, it's a real chore. So that's pretty much what the PySnooper saves you from having to do.
So for people who are feeling the pain of dealing with these print statements and log statements as their debugging mechanism, or who have been fighting with the built-in PDB debugger for trying to figure out how do I actually get access to it, particularly if you're running in a web request and you don't want to use some of these debugging tools that open a socket, what's the actual workflow for getting started with PySnooper and starting to use it for investigating problems in their code base? And what's the life cycle of a PySnooper statement once you incorporate it into the code? Is it something that you would then need to go back and remove like you would with print?
So I'll start from the end. Yes, you will need to go back and remove it. It's the same as print in this regard. Now, what would be the workflow for someone who wanted to use PySnooper? You could read the README, which is pretty short, but I'll try to make it shorter. Pip install PySnooper, import PySnooper in your code, and then add the PySnooper.snoop decorator to your function. Now, there are a bunch of arguments, like optional arguments that the Snoop decorator can get, but you don't really need all of them to get started. Just the three things I said: pip install PySnooper, import PySnooper, and decorate your function with PySnooper.snoop, and PySnooper is already working. And if you got more arguments, you can pass for the first argument, you can pass the file name and then instead of writing to standard error, it would write the same kind of text dump to your file. And there are a bunch of other useful arguments. Like you can set a different det. The default is det equals 1, and this means that only code lines in your function are going to get traced. Now, if you were to set det equals 2, it will also go into any function that your function calls. If you were to set det equals 3, it would also go into any function that is called by a function that your function calls, and you get it. So that is one useful setting there. I think there are 10 different arguments there that you can modify to kind of tweak it to your needs. But the very basic usage is just the three things I said at the top. Just pip install PySnooper, import PySnooper, and decorate with PySnooper.snoop.
So for somebody who is using PySnooper, what are some of the types of information that it surfaces, and how would you incorporate that information into the overall debugging process of identifying what's the control flow for the logic, what are some of the branch points, how do I figure out what the values are given these different operations, and understanding how to actually fix the problem that you're trying to debug?
Most of the information that's provided is what I mentioned so far, which is the order in which the lines ran. Because every time a line runs, it produces a line in the text dump. So you basically see the lines running one by one. Every time a variable gets changed, you're going to see the output and the value of the new variable as a new line. So this is basically 90% of what you need to debug. Now, sometimes people would also like to call arbitrary code, or maybe call a certain function and to get its value at a certain point. So we also have an argument for that called watch, and it works basically the same as a debugger. You just put any arbitrary argument that you desire, and you're going to see its value. And if its value changes, you're going to see the new value every time. Now, watch is one of the arguments that we've got in PySnooper, and if you go into the PySnooper documentation, you're going to see the documentation both for watch and for all the other arguments that we have. It's a pretty short documentation, just a couple of README files. I've intentionally kept PySnooper as simple as possible.
And so I think that's a good opportunity to talk through a bit about how PySnooper itself is actually implemented and some of the evolution that it's gone through from when you first had the idea of it and to where it's gotten now, and maybe some of the types of projects that you were testing it with to guide the direction of where it ended up.
Okay, so these were a few questions in one. I'm going to tackle them one by one. So you asked about how PySnooper works, right?
Yes.
Okay, so PySnooper works by using sys.setTrace. Sys.setTrace is the mechanism that CPython provides, and that's basically any kind of debugger that you've ever used uses sys.setTrace. And also any kind of coverage measuring tool in Python also uses sys.setTrace. What is sys.setTrace? It's Python function that you call it and you pass a function into it called a tracing function. And you tell CPython, please use this tracing function. Please, for every line that runs in my code, I would like you to call this tracing function with information such as which line ran and what kind of event happened, as in just a regular code line or a function returned or there was an exception, and any other useful information like the exception that got raised or the value that the function returned. And basically any debugger or any coverage measurement tool works by putting its own logic into that trace function. For example, if you were writing a debugger, then some logic you might put in your trace function is to see whether the current line is on the list of breakpoints that you've got, and if it's on the list of breakpoints, then you should pause the program at this point. Or if you were writing a code coverage tool, you would look at the current line that's running and you would mark that in your database as a line that did run. So at the end you can give a report of which lines ran and which didn't. So in PySnooper, my logic was different. I used sys.setTrace and I put my trace function, and my trace function, well, what it does is it checks whether this is a line that we should be tracing. It checks whether the variables got changed from the previous line, and it outputs a line saying which line ran, and if any variables changed, which variables changed and what the new values are. So that's basically how it works. So CPython does the heavy lifting, and I just do a little bit of logic around that. Now, sorry, I forgot the other parts of your question.
Just curious about some of the ways that the implementation of PySnooper has evolved since you first began working on it and having the idea about it, and some of the types of programs that you were working on that influenced the direction that you took it.
it's interesting to talk about how it evolved. It mostly didn't change. It mostly, I mean, once I published it and it got very popular, we're going to talk about that later, and got lots of contributors. Lots of people added features and fixed bugs and polished it, but mostly the basic operation stayed the same, and it mostly stayed the same, just faster and stronger and better. You know, there is one interesting thing to talk about here. I used the sys.settrace, and one of my contributors, Alex Hall, we're also going to talk about him later, he found that there is a sort of optimization. Well, actually, it's not exactly optimization, but a more low-level way in Python to control the tracing function, which is something called f_trace. Now, he added it to the code, and it worked, and it allowed using PySnooper as a context manager also. And I didn't know how it did that. That was magic. So I Googled it, and I assumed I would find information about it in the Python documentation, but I didn't. It was some sort of magic that he found from inspecting a different debugger. So after we published his PR, at some point I thought, why not add this to the Python documentation so other people are going to know about that? So I made the PR to Python, and I've contributed to CPython in the past, but it was years ago. And recently CPython moved to GitHub, which is a great move in my opinion. So this was my first time contributing to CPython on their GitHub. So I kind of learned the new process. If you got a bunch of bots to do things for you, it's pretty cool. And I wrote the documentation that explains what ftrace is for other people who might want to use it. And I wrote it, and we did a few back and forths with the developers there for a few weeks. And eventually it was accepted, so now it's part of the documentation. So I'm happy to have that this resulted in a contribution to CPython itself. Yeah, I'm gonna now move on to your other question. You asked what kind of project I used PySnooper on that determined how it's evolved. The funny thing is, the first time I've actually used PySnooper was well after I published it and it became famous. So I didn't even use it at all when I published it. I know it's pretty funny. It's a thing I wanted, and I never used it until then. But yeah, I just always use a debugger, and I meant for PySnooper to be as a sort of a last resort tool when you can't use a debugger. And I always use the debugger, so I was good. Now, I did use it like, I don't know, maybe 10 times in the last couple of months. And I used it at my job at Bluevine, and I've also used it when debugging scripts of my debugger Wing IDE. So it's very useful for these kind of times where something is convoluted and you can't, it's like I write scripts for my IDE, and my IDE runs them in some convoluted way, and I don't know how to debug the scripts that my IDE runs. So if I push a PySnooper decorator in there and I tell it to write output to a file, I know for a fact that I'm going to get output in that file. So that's what I really like about PySnooper. It gets the output out no matter how difficult it is. So and when I used it for the first time, it was pretty much exactly what I wanted. And the only thing I felt was missing was that it should output the absolute path of the file every time it outputs the lines it ran. So I added that as a quick feature and made a new release with that new feature. But other than that, it worked exactly like I wanted it to, so I was happy about that.
And so you had mentioned that some of your motivation for creating PySnooper was to address some of the issues around using print or log-based debugging and to make it easier to be able to get the full context of the application as you're trying to debug it without having to do all this back and forth. And I'm wondering if you can just talk through some of the initial goals that you had for the project and some of them that you had to either abandon because they were technically infeasible or not useful, or maybe some of the initial assumptions that you had about how it was going to be used or how it was going to work that didn't quite play out how you had anticipated as you got further into the weeds of implementing it and using it and promoting it.
Well, that's going to be a fun question to answer. You know, I've been doing software development for a long time. And I learned a long time ago that when you start a project, you have a certain vision. You imagine something about how this project is going to be. And once you start working on it, and especially once you let users use it, you have to pivot. You have to understand that things that you thought were easy are actually difficult. And things you thought are not worth it are actually worth it. And you end up changing your project. I've kind of gotten used to it and taken it for granted. Now with this specific project, it kind of all played out exactly the way I wanted it to, which I guess I'm lucky about that. I thought about this idea in the shower. I thought that'd be a cool thing to build, and I had a sort of vision for what it's going to be. And then I built it, and then it was exactly what I wanted it to be. So I guess that's a one in 100 in a software development career. So I published it, and I was very happy that it got so popular. I've written a bunch of open source projects in the past, and I did have one that reached this similar level of popularity like this one, but most of the time it doesn't happen. So I was very happy that happened, and the project pretty much turned out exactly how I wanted it to be. So I was very happy about that.
And then in terms of the actual implementation, what are some of the edge cases or technical challenges that you encountered while working on it, either in how Python itself operates or in how PySnooper interacts with the program that you're debugging?
Sure. So I said before that I really like to use the debugger when I program. Now the irony is I couldn't use the debugger when I was programming PySnooper. Why? Because as I said before, both PySnooper and the debugger, they use the sys.settrace function that CPython provides. Now, if you're using a debugger, then it's telling Python to use its tracing function, and then you use PySnooper, and it overrides the tracing function set by a debugger. So the minute you start to use PySnooper, your debugger stops working. Assuming you're debugging PySnooper. So that was really annoying to me. I wanted to debug PySnooper when I was developing it. I wanted to see why it's not doing what I thought it should be doing, and I just couldn't do it with the debugger. So I ended up using print statements, which is pretty ironic. And I also wanted to use code coverage tools for my tests. We have an extensive test suite, which I'm very proud of, and I wanted to use the coverage measurement to see which lines are being covered, and I can't do that because coverage measurement also uses sys.settrace, which gets overridden by PySnooper. So what I would like to see, a change I would like to see in CPython, is that instead of having just one kind of tracing function, that you'd be able to have an entire stack of tracing function. If, for example, I'm running a code coverage measurement tool, which sets its own tracer, and then I use PySnooper, it's going to set its own tracer on top of the previous tracer without overriding it, so both tracers are going to be active at the same time. Now, that could be a good subject for a PEP. Personally, I think I floated the idea on Python Ideas and the Python Ideas mailing list. And there wasn't much enthusiasm, which I can understand because the people who develop debuggers and code coverage tools are a pretty niche crowd. So there wasn't a lot of interest, but that could be a change in CPython, which will make it easier to write debugging tools. But yeah, it also add complexity to the project, so I'm not entirely sure it would be worth it. Maybe it would be worth it to make a branch, a fork of CPython that would be used only to develop debugging tools for actual Python. But yeah, that's still a niche use case.
Yeah, it's one of the challenges of having a community that's as broad in scope as Python is that, as you said, for something that's so niche where there's only a small handful of people that are doing it, that's a small percentage of the overall Python community, which is still a fair number of people, but in the context of the people who are trying to drive the language forward and ensure that it meets all of the needs of everybody who's using it, it's difficult to get the focus and attention and buy-in necessary for being able to push forward a feature that's going to be useful for such a small group of people. And so yeah, it's interesting how that plays out in terms of open source and community management.
Yeah, that's right. When I was younger and more stupid, I would suggest lots of things to Python Ideas, and most of them were pretty stupid. And once in a while I'd hit on something that was approved, but most of the time I would suggest things and everybody would knock them down. And especially Guido would knock my things down, which is really funny for an inexperienced developer. Like you're posting an idea and Guido says, no, this is not good because of this and that. And then after he says that, like 5 more people after he say, no, it's not a good idea because of this and that. And I'm like, thank you very much. Guido already implied I was an idiot. And now you guys are so great for helping him. But I know that as frustrating as it was for me, they were doing the good thing by making sure that everything that goes into CPython goes through a lot of scrutiny because it affects a lot of people. So I think they were doing the good thing, even though it was frustrating to me. But when people do make suggestions on PySnooper and try to improve it, I try to be as nice as I can be. Some people do a really great job in their PRs and their issues, and they're really easy to work with. Some people I have to correct them again and again and correct their mistakes and teach them about how to contribute to open source. But I always try to do it in the way that's most encouraging. Like if they did something good, I would compliment them on something good that they did. And I would thank them for trying to contribute because I know that not everybody not everybody has contributed to open source, and for some people it's a very frightening prospect. So I try to be as welcoming to newcomers as possible.
Yeah, open source community management is definitely a challenging beast, and one that has a lot of different aspects to it. And then there's also a lot of different aspects to actually contributing to an open source ecosystem, where part of it might be contributing to the actual project itself, in the case that you're discussing as far as proposing these PEPs or wanting to implement additional functionality in the Python language, or it also might just be in terms of building on top of it, as you've done with PySnooper. And another case of that is a project that I found a little while ago called Snoop, which builds on top of your work, and from what I was able to tell, adds some additional features in terms of user experience and maybe some additional functionality. And so I'm curious what your initial reaction was if and when you found out about it, and maybe some of the ideas that you have incorporated back into PySnooper itself after playing around with some of the functionality that they added, and just your overall reaction to that project and the fact that you gained enough popularity that somebody is building another layer on top of what you've done.
Right. So it's not just somebody. The guy who made Snoop is called Alex Hall, and he's the top contributor to PySnooper. So he's implemented a lot of features, fixed a lot of bugs, and he also helped do a lot of reviews for other people who implemented features and bugs. So he's been the most helpful contributor I've had. Now, there were a bunch of his features that he wanted to add that I felt were nice to have, but they were not worth the added complexity and the long-term maintenance burden that they would create. Now, we had back and forth about it, and he just wanted to implement them, so he made his own fork. So I'm happy he made his fork, so he could do what he wanted without me being the bad guy and telling him he can't do that. I'm a little bit unhappy that they call it Snoop, because I think it might be confusing to people. I mean, when you use PySnooper, the decorator is called Snoop, so having his project called Snoop could cause confusion between the projects. So I'm unhappy about that, but that's his decision, and I don't have a trademark on Snoop, so I can't really enforce that. So I'm happy that he has his fork. I don't remember whether I merged anything from it. It's possible that he submitted PRs that he first got into Snoop, so I can't recall any of these. I do recall looking at the project with me and seeing that there were a few nice to have features, but nothing that is really a huge difference. And I think there is a mistake that developers make. They're really into their thing. I mean, we were both working with PySnooper, and I think that developers kind of tend to be really into their thing and not appreciate how different the real world is. Well, I know I'm putting it in a way that's kind of difficult to understand, but for most people who use PySnooper, they would never touch the more advanced features. Never. Most people, when they use code, this is something I learned when I started working in a big company. Like for me and you, if we use a package like PySnooper or requests or Django, it is very clear to us that we're using a package someone wrote, and it has features, and it has documentation, and you can read about them, and it has all kinds of things that you can use. But most programmers don't really care about that. If they use PySnooper, it's because they saw some other developer use PySnooper, so they copy-pasted his code and to their code and kicked it until it worked, and then it worked, and they won't even bother to check the more advanced features. So the people who use the more advanced features are kind of a minority. So I'm not saying not have advanced features, but realize that their benefit compared with the maintenance burden isn't that great. That's what I'm saying.
Yeah, one of the most important and most difficult jobs of anybody who's maintaining a project is understanding when to say no to a given feature. One of my favorite sayings is that open source is free as in puppy, where somebody can give you a puppy for free, but then you're on the hook to actually take care of it and make sure that it's well fed and well maintained throughout the entire rest of its life.
Oh, that's a nice metaphor. I never had that one before.
So, as you alluded to before a couple of times, one of the notable aspects of your work on PySnooper is that shortly after you launched it garnered a lot of attention broadly within various communities. And so I'm wondering if you can just talk about some of the strategy that you used to gain that level of popularity, and a little bit about how that visibility has affected the long-term popularity and use of PySnooper, and maybe some of the future direction of where you're planning on taking it.
Right. So I'm guessing that many of our listeners might be interested in writing their own open source projects and maybe get them to be very popular. So I'm gonna share what I did and what I think about what contributed to PySnooper's popularity. So the first thing that's very important, you gotta have a README. It really explains what your project is about and what kind of needs it's fulfilling. Now, it's important to have a good README, a good tagline for your repo. And to understand this is now a marketing effort. You now have to convince the user in like, I don't know, 20 seconds or 30 seconds that you've got something interesting. Show him something cool. When someone, and I mentioned this in my previous answers, people are less interested in your project than you are. And this means that if they're going to your project homepage, they have like 20 seconds or 30 seconds of attention. They are bored. They want to do something else, but they're thinking maybe you could entertain them. So it's really important to get your message across. So with PySnooper, I kind of described, the tagline was, PySnooper, never use Sprint for debugging again, which I think kind of hits it home. I mean, people can relate to that. And I kind of made the explanation in the README of you trying to debug and you want to know the values of the variables, but getting a debugger is too difficult because you're in a corporate environment. And I kind of described the exact scenario that I've seen play out 1,000 times. And then I had a sort of a quick start example of how to use it, instead of linking to documentation and having someone go through a complicated tutorial. So it's really important to get that README straight so people could be interested to try to learn more. So that's one aspect. The other aspect, you got to do sort of a launch. I mean, when you make it public, you should post to Hacker News and post to Reddit and post to wherever else you can think of. You should get a few of your friends to upvote it in the first few minutes when you're posting. It's important. I would say this is the only kind of dark pattern that I use. I mean, it's kind of cheating, but you only need like 3 or 4 people to get to the front page for a few minutes. And once you've got that, you're not really cheating anymore, because if people like it on the front page, they will upvote it. If they don't, they won't. At that point, it depends on how likable your project is. With PySnooper, it got more points on Hacker News. It got to be number 1 there. So lots of people started on GitHub. And once lots of people started on GitHub, then it got to the trending page on GitHub. And then more people found it through there, and more people started. And then it got to be number 1 on the trending page of GitHub. And then it really exploded. I got lots of stars and contributors. I think at this point I'm almost reaching 13,000 stars, which is insanely unproportional to the project, because I think like projects like CPython or NumPy have like, I don't know, like I think 30,000 stars. So obviously my project is not half as complicated or half as whatever as CPython. So I guess I was just lucky to get all that attention. You asked how it influenced the project. Well, I got lots of contributors. Lots of them have been easy to work with, like Alex Hall with all the super helpful pull requests and issues. Lots of people like submitted issues for stuff that didn't work for them, and obviously no one ever yelled at them before for not including information in their issues. So I would get just random, like for example, today or I think yesterday, someone just said, hey, I got this exception when using PySnooper, and he just put it in with no context about what he was doing. And Alex and I had to kind of question him until he gave us the right information. So lots of people like submit issues in a way that has no information. And also in the last few years, lots of people in Asia got into open source. So there's lots of people who just create issues in Chinese. Just write it in Chinese and without a thought about whether I speak Chinese, and I don't. So that's been pretty funny. You know, as long as I'm speaking about these kind of issues, when I started doing open source development, mailing lists were a big thing. Like every project had a mailing list, and I personally hated it because it was weird that you had to subscribe to something to ask a question. So now there is no mailing list for PySnooper, as there isn't one for most projects. People just ask questions on the issues board. But we're having fun, and I've got lots of contributors. I think I've got around 20 contributors. So the popularity improved the project. All the contributors came in and they improved and polished the project. So I'm very happy about how it turned out.
And overall, what have been some of the most interesting or unexpected or challenging aspects of creating and maintaining and promoting PySnooper, and maybe some of the opportunities that you've gained as a result of its popularity?
I've had fun speaking about it in a few conferences. To be honest, I think I mentioned most of the interesting or unexpected things above that I had to say, but I had fun speaking about it in a few conferences at PyWebIL and PyCon Israel and PyCon in the Czech Republic, and also in GeoPython in Basel, Switzerland. So that's been fun, and that's pretty much it. I try to I've been very tempted to maybe add more features, add more fancy stuff, but I think that the strength of PySnooper is that it's so small and unambitious. So I try to keep it small, because if I start adding more ambitious features to it, I think it is going to ruin the project. So that's pretty much for me. I mean, as far as I'm concerned, the only thing I'm interested with regarding this project is long-term maintenance and reliability. Make sure it fits with the new Python versions. Once in a while, someone submits a feature request. It actually happened a week or two ago, and I work on it. But mostly, the project is going along fine, and I don't plan to change it or to add any major features at any point.
Are there any other aspects of your work on PySnooper or the state of the art in debugging within the Python ecosystem, or anything else related to your work that we didn't discuss yet that you'd like to cover before we close out the show?
Sure. One thing I said, which is actually not my work, you've mentioned PDB earlier in the episode. Now, I hate PDB with a passion. I hate it so much. I remember using it like once or twice when I was starting my career, and I wanted to use Q as a variable name, just because sometimes I use random letters as a variable name when I'm debugging. And when I typed Q, it immediately exited. And I was so angry, and I never used PDB again. I was very angry about that. But I learned there is a different program called PUDB, which is it's similar to PDB, as in it's a debugger that you use in a shell, but it has a sort of graphical interface in the shell, which kind of reminds you of the Borland C interface from the past. It's really cool. It's basically like PDB, except it actually shows you your code and has sort of a graphical interface, but it's still in the shell and doesn't require a GUI. It's like in Windows or whatever. So that's a pretty fun tool. Once in a while, when I get shell access to something and I want to debug it, I use PUDB. So that's a pretty fun tool. I think everybody should at least give it a try, because it's been useful to me, so many times.
Yeah, there's another project along the same lines that's called PDB++ or PDB-PP that will transparently work in place of anywhere you use PDB for the built-in module, and just adds a lot of niceties in terms of syntax highlighting and better visibility of the code that you're currently within the context of, but it's not quite as full-featured as PUDB, so it's sort of a step in between. But there's definitely a lot of value to be had in terms of understanding how to use a traditional debugger for being able to step through the code, and then being able to have things like your work on PySnooper available for being able to just quickly get a good overview of what is the overall logic flow and the variables that are there. So understanding what all is in the tool chest and when it's appropriate to use it is definitely an important skill for any engineer.
Right.
All right. So for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose PyCon US. It's the largest PyCon event. It's the one that I've been to a number of times and plan to be at again for the spring. So they actually have the call for proposals is still open until December 20th if you're listening to this before then, and registration has been opened, so I hope to see a lot of people there again. And with that, I'll pass it to you, Ram. Do you have any picks this week?
Actually, I want to say something about your pick. I submitted a talk proposal to PyCon US. Really hope it gets accepted. It's a talk I gave in Israel about live coding and music synthesizer. It's a really fun talk. So I really hope they can accept me, so I hope I'm going to see you at Pittsburgh. Regarding my pick, I would like to talk about something that is completely unrelated to programming, but I think it's a fun thing that people should know about. It's called nonviolent communication. It's sort of a school of thought about expressing your emotions and interacting with other people. Like around 15 years ago, a friend of mine sent me a YouTube video of this guy explaining nonviolent communication, what it's about, and that kind of video kind of blew my mind and really changed the way I interact with people. If I put it in one sentence, it's about expressing your emotions in a way that is completely free of judgment and separated from your thoughts. As in learning how to listen to your emotions in a way that's separated from your thoughts. And you get to learn a lot of things when you're doing that. So I'm going to link to the YouTube video in the show notes, and hopefully it's going to blow your minds as much as it blew mine.
All right. Well, thank you very much for taking the time today to join me and discuss your work on PySnooper and some of your experience of helping to grow the community around it and your experience of promoting and marketing an open source project. So it's definitely an interesting tool and one that I am sure I'll have cause to use in the near future. So thank you for all of your efforts on that front, and I hope you enjoy the rest of your day.
Thank you very much for having me on, Tobias. It's been a pleasure.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.